Okay, so our inequalities, in means not, so we have not equal to. So this first one here is your less than, greater than, less than or equal to. So, are you guys familiar with that symbol with the bar underneath? Yeah, less than or equal to. And this would be greater than or equal to. There's actually one more symbol that I wonder if you know what it is. What do you think this one is? Not equal to, exactly. So usually we use inequalities when we're comparing two numbers, for example. So if you wanted to do, I don't know, 5 compared to 8. Which symbol would I put in between these two to make it correct? Yeah, 5 is less than 8, right? So I don't know how you learned it. I always learned it as the inequality symbol is a Pac-Man, and Pac-Man's always going to eat the bigger number.
Or what I learned in elementary school, it was the alligator or crocodile eats the egg.
Sure. However whatever you want to do, Pac-Man, alligator, crocodile, dodo bird, whatever you want. It's always going to eat the bigger number. So when I go to compare, make sure what happens when I'm in negative land. Yeah, so now it's actually negative 5 is greater than negative 8, right? Because this is now the bigger number. When I have two numbers, tell me if this is true or false. Is that a true or a false statement? That's true because I have the less than or equal to sign. Negative 5 is obviously equal to negative 5 because it's the same number. So as long as I have that bar underneath, that's okay. This is still a true statement.
What if you had it the other way?
It actually wouldn't matter. This is still a true statement also. Good question.
So, okay.
Yep. So they're both true either way. Okay?
I know this.
Well, we're usually going to have, you guys have been comparing numbers for a long time now. We're going to introduce variables into this though. So for example, let's say no, I'm right here.
Yeah, there you go.
You want this on there still?
Yeah,
Okay.
I couldn't see the not equal to.
That's all right. So let's say I gave you something like this. What does that mean?
X is less than 3.
X is less than 3. So this is representing all the numbers that are less than 3. Right. It could be 2, it could be 1, it could be any negative number in the whole wide world. Could it be 1.5? Yeah, 1.5 is less than 3. Could it be 2.9? Could it be 2.99? Could it be 2.99999? Could it be 3? No, because 3, right, if it had the line underneath it could, but if it doesn't have the line underneath, 3 is not less than 3, so that would not be a true statement. So this, you would say it out loud as X is less than 3. And it represents all of the numbers in the whole wide world that are less than 3. But it does not include the number 3 itself. We can also graph these. Do you remember having to graph these? Have you ever done that on the number line? Well, if you haven't or if you forgot, all you have to do is draw yourself a number line. You don't need to give me all the numbers in the whole wide world. Just a couple of the ones around what you need. Maybe I'll throw in a negative 1. If I wanted to graph this, what was that?
Could X less than 3 be a negative number?
Sure, because isn't negative 2 less than 3? Yeah. There's so many answers to this. that it's not just one single thing. When we have equations, right, when it's an equal sign, we usually only get one answer. X equals 7, and that's it. Here, there's an infinite number of answers. It's all the numbers in the whole wide world that are less than 3. Okay? So sometimes we display all of those answers on a graph. So we're going to put a dot at 3. But do you remember the difference between the open dots and the closed dots? Do you remember that? Is that ringing a bell? No? We're going to make a little chart over here. If you have the bar underneath it, you're going to put a closed dot on your circle. If you don't have the bar underneath it, you're going to have an open dot.
What is this?
This is for when you're going to make your graph. So, because I have one of the symbols without the bar underneath it, I'm going to put an open dot at 3. Okay? So I put an open dot at 3. And then, in order to show all the answers, we shade over them. So we draw, like, usually a heavy arrow over all the answers. So I want all the numbers that are less than 3. Well, where are the numbers less than 3? This way, to the left, or to the right? To the left, right? So usually what we do is we kind of make a thick line, and we put an arrow that way. So that shows all of the numbers in the whole wide world that satisfy this inequality. Those are all of the numbers. Make sure you have an arrowhead here to indicate that that's going to go on forever. So any number that I'm shading over is an answer. If I plug in 1, 1 is less than 3. If I plug in 0, 0 is less than 3. Anything that you shade over. Did I shade over the number -1? Yes, I did, because this arrow means it continues forever. So even though I literally didn't make my line, if it's got an arrow, it's going over everything this way.
Negative infinity.
Correct.
Happy Easter. Why?
I don't know. I didn't write it.
Random people nowadays.
So let's try another one. Let's say I want to represent all of the numbers greater than or equal to -1. I want to represent this on a graph. So again, I'm going to go ahead and make a number line. And then I just have to put a dot at -1. Well, which kind of a dot do I use? We can look at our chart here. Closed. If you have, do you know why, by the way? Why is one open and one closed? What's the big deal? Right. So when I use the closed dot, that means that I can use that number as that's part of my answer. I can -1 is greater than or equal to -1. But up here, 3 is not less than 3, so that's why I had to have it open. So if I want to include the number as part of the answer, I put a closed dot. And that's how you know. If you have the bar underneath, closed dot, no bar, leave it open. Okay? And I want all the numbers greater than -1. Well, where are the numbers greater than -1? To the left or to the right? To the right. So I just shade this way. Make sure you put an arrow. Yeah, Sam? You are right until something happens. I'm going to try and trick you now. Are you ready? Or maybe here, before I try and trick you. Everybody graph for me what you think this looks like. X is less than 0. Give me that on a number line.
Any negative number.
True, but show me on the number line what that would look like.
So it all just depends on the circle, if it's open or closed. And the arrow means it continues or doesn't continue. Okay.
Okay, everybody made a graph?
No.
Sorry, go ahead. Okay, what kind of a dot should I put at 0? Cohen.
It's open.
Open, yes. Open dot at 0. And then I want all the numbers less than 0, so I should shade to the left or to the right? To the left. If you're ever not sure, just take a number that you shaded over and plug it in. Is -1 less than 0?
Do you have to draw the squiggly thing? Or can't just straight?
Oh, you can just make it straight. I'd try to make it. The problem is, and a lot of people draw it on top of the axis itself. So they draw it like this. First of all, sometimes kids make their open circle so small that it looks closed. And then I'm like, well, I can't tell. So I always draw it above so I can clearly tell if it's open or closed. And then if you do it like this, like it's hard to see that that's, you know what I mean? So if you're going to draw it on the line, at least make it obvious which way it's going.
I'm over here.
Right. Don't draw it so small, like right on top of it that I can't even tell where. And then they'll put their arrowhead like here. I'm like, how the heck am I supposed to see that? So I just draw it above so you can see it. But it's the same thing if you draw it on the line. Okay, I'm going to try and trick you. How would you read that out loud? 3 is greater than x. Go ahead and graph that one. Graph how you think that would look. Okay, did you give it a shot?
Yeah.
Joe?
Three with an open dot.
You're right about that. And then which way do I go?
This one.
To the left or to the right?
To the negative.
This way?
It's the other way.
So Joe is saying this way.
I'm saying right. Yeah.
So here's the problem, right? Kids get messed up all the time if the variable's not first. When the variable was first, you guys, these were pretty easy, right? It was pretty easy to figure out which way it went. When the variable is not first, it's not quite as easy. But it can be if you just put the variable first. Me personally, if I read something like this, automatically I'm like, nope, I'm not dealing with it. I'm going to rewrite this so that the variable comes first. So basically, I almost am going to like do a mirror image. I'm going to flop the whole thing over. X, see how X has the arrow being pointed at it right here?
Yep.
So I just pointed at it, 3. I just flipped it over, and I just make sure that I didn't mess up. X had the arrow pointing at it, X still has the arrow pointing at it. This is now super easy to deal with, and it's actually the first one that you did. X is less than 3. So if you said shade to the left, you were right. Don't forget that you can always check yourself. So me, I like doing this. I rewrite it this way. That's what I do. Are you wrong if you don't? No. But it's so easy. And guess what? There's another helpful little hint. If the variable comes first, and this only works if the variable comes first, this inequality symbol tells you which way the line goes. It points at it. So this is saying, hey, go this way. See how the arrowhead matches? Look at all your other ones. Look, the arrowhead went this way. The arrowhead went this way. The arrowhead went this way. See that? See how they match?
Only if the variable is first.
If the variable is not first,
It's not going to work.
right. So that's why I like to rewrite it. So it's like you just flop it over, mirror image the whole thing, flop it over. They mean the same thing. So this 3 is greater than x, but that's so weird to think about it. If you just read it backwards almost, x is less than 3. X is less than 3. And then it's so much easier to graph, to think about, everything. I want all the numbers less than 3. And there they all are. Which one?
I can't see.
Do you want to move up to the seat?
You can just scroll up the paper. That's I said up. I meant down.
Oh,
Yeah, I couldn't see it.
okay.
Start 3, then you go. Why did you go 5 instead of 3?
What do you mean?
5 spaces. It should have been on negative. It should have been
Oh, this line, doesn't matter how long this line is. It just matters which way you're drawing it.
Oh, I think
Yeah.
I get it.
So let's try another one where the variable is not first. Try -2. Try that. Give me a graph of this. So hopefully everybody got the dot right. Open or closed? It's going to be closed, right? Because I have the bar underneath. So I want a closed dot at -2. All right, now it's just a matter of which way am I drawing it. Before I even do it, I'm rewriting it. I'm going to flop this over x. Now x is getting eaten, so I write it like that. And just mirror image, flop it all over. So now I'm really graphing x is greater than or equal to -2. So where are the numbers greater than -2? To the right or to the left? To the right. And remember, you can just use the trick. This arrow, same thing. There's my shaded over arrow. Everything this way is going to be an answer. There's one more symbol that we haven't really talked about and how to graph it, the not equal to. This doesn't come up that often, but it's pretty easy, so we might as well just include it. How do you think you would graph something like x does not equal 3? If x doesn't equal 3, what could it be? Literally anything else.
So you X out 3.
Kind of. So how would I not include the number 3?
Crossing it out.
Yes, I'm going to have an open dot at 3 because I don't want to include 3 as part of my answer. Oh, I didn't really give myself much room. Oh, well. I don't want to include the number 3. Oh, I should have done it up here. Whatever. But I can have everything else. So I'm going to have 2 arrows, one that goes this way and one that goes this way. So that's how you handle just a x can't be that number. Just an open circle at that number, shade everywhere else. So, I don't know, just do x can't be 0 for me. Show what that would look like.
I have the solution.
What kind of a dot at 0? Open, and then just shade both ways. All right. Easy enough? Okay.